Hello and welcome to this video lecture on Chapter 3. So the things we'll be talking about this week are why is terminology important when you're talking to others about your databases? What are the terms that are the values in a database? That's how you relate them. Some terms about relationships and integrity related terms. So there's different ways that you can enforce integrity in a database. And so those are the things that we'll be talking about in this video lecture. So you can think about database terminology being like any other kind of language that you're starting to learn. In order to speak that language with other people that know that language, you have to be able to understand those terms, understand what people are talking about, so that when you're wanting something, you can speak in database terms of exactly what you want. And as you can see here, that you're going to gain some credibility if you can talk intelligently about databases. Specifically, you want to be able to define the special ideas and concepts of a relational database. You want to express and define the database design process. We talked about that in the last chapter. And anything that's related to a relational database, what they're doing, why they're doing it, and so on. So if we break these different terminologies down, we can put those into different categories. One is value related, one is structure related, the other relationship related, and then integrity related. So when you're studying out of this chapter, think about putting it in these four categories and what can you tell me about the terminology in these four categories without going back and looking at your notes. So in terms of value related terminology, we have data. If you remember, data are the raw facts that you store in your database. They remain static until you change them either manually or automatically somehow. That is, there might be a program that's written that goes in and changes those values. But for the most part, they're going to remain static. Then we have information. And if you'll recall, that's data that processes and puts into context, which then makes it meaningful. And so if you look here, you might have data is what you store, information is what you retrieve. So data in, information out. Information, unlike data, which is static for the most part, is dynamic. And it's constantly changing relative to the data, depending on what you're pulling out. Also with information, you can process it and present it in different ways. And that's what we mean by giving it context, and therefore it becomes meaningful information. So when you're designing a database, so that's the meaningful information is what you're trying to provide at the end. And so that's going to tell you what kind of data you're going to need to collect so that when they put it into context and retrieve it out of the database in some organized way, it becomes information. Another term that you need to get familiar with is the term called null. Null is the absence of information, the absence of data. There is nothing there. Okay? So that's different than a placeholder. So null does not represent a zero or a text string of blank spaces. Right? So when you're doing that in a spreadsheet and you think there's no response, you should just leave it blank. If you put in a zero, that actually has some kind of meaning that you saw it and you didn't think it was meaningful, or you saw it and that was the meaning, but yet there was nothing there. And so null in a database is the absence of nothing. You got to keep that in mind. It can mess up your calculations, and we'll show you or talk more about that here in a moment. So I guess an example would be a bank account balance. A number of tickets available. If it has a 0 in there, then that has meaning. It means you didn't get any tickets. But a null means you didn't get to it yet. You haven't entered a value for that yet. You don't know what that piece of data is. So just to be clear, if you need a 0, then use a 0. Otherwise, when you're doing something like an average, if there's a 0 in there, that takes up a value for the number of things you're getting the average for. Well, if you really don't have any data for that, it should be included for part of the average. So it's like when I have a bunch of students that have dropped the course, but yet they're still on their rolls, do I give them 0s for all the exams? Well, when I go back and do an average for that, then that makes the average really incorrect because those students really never took the exam. And so hopefully you're getting what we mean by null and the problems it can cause if you put a 0 for the null. Also, when you're entering data, if you need a blank space, then enter a blank space. That blank space is entered with, could be a quote and then a space and a double quote and then another quote, or it could be a single quote, a space, and another single quote. Now that's a space. Now something like that, 2 quotes together, that might be the null. But you never want to put a blank space in there. This space right here, that actually has meaning to a computer. It's just like any other character that you have on your keyboard. There is a byte for that. It has a value. You also want to be aware that when you're copying and pasting, sometimes there's a space there, and if you do that in your My IT Labs, that's going to cause you problems. So beware when you want to have a null value. This right here, where I didn't put a space in between, sometimes referred to as a 0 length string. Right? You can use that to indicate that the data does not exist. So sometimes like a middle name. Right? So the types of null values, that's what this list here is for. Right? Missing values may be the result of human error when you're entering things in. Unknown values may mean the value has not been defined or identified yet, and it could be actually unknown, similar to that accounting example I used earlier. Does not apply. None of its acceptable values applies to a particular field. Examples might be salary versus hourly. You would not use both. So you'd have one column that might be salary and another column that might be used hourly. When I say column, that's the same thing as a field attribute. And so if you have somebody that has a salaried value, you'd put in their salary. But then in the hourly column, they'd have a null, or vice versa. You wouldn't put in a placeholder or a blank or anything. So the concept of does not apply versus is not applicable. So in the example of a salary versus hourly, you literally does not apply and will not be used for one of them. Right? You either have salary or you have hourly. If you're collecting data, let's say on hair color, and someone has blue hair, but yet the only responses are red, black, blonde, or gray, then the choice of is not applicable would be used because you didn't have a choice for blue hair. When you design your input values from, say, a drop-down list, you probably want to include the not applicable option, or you would say NA. And when somebody chooses that, then you know that they didn't accidentally leave it blank, but it was actually considered that the other options they were given weren't valid. And so they put in non-applicable. All right, hopefully that makes sense and you're taking good notes here. Some other information to keep in mind is that when you're using Access and you make a field required, then the user who's using that database has to enter a value. When it's not required, then if they don't put anything in, a null will occur. That is the absence of information. And so that has implications on your math calculations. So anything that is math-oriented or number-oriented, a null can have, change the results dramatically. So that could be anything like quantities, balances, currency, sales, and so on. Right. When in doubt, think of the business rules that you'll be needing, and then the processes that go along with those rules. How does somebody do something, or how do they put the information down on a piece of paper or in a form somewhere? All right. So moving on, the next category is called structured related terminology. And these are your table relations. These are the basic structures or chief structures in a database. One is your data table. So this data table is the most common type in a database. It stores data to supply the information. Okay. You can also have a validation table. So it stores data used to implement your data integrity. So it might represent static things that don't change very often, like city names, product categories, etc. So you might have maybe zip codes. You might have a validation table that has zip codes in it that represent different cities and states. And so when you have the user enter data in the data table or form, you might want to validate that form. Does that zip code match up with the city they entered? If it doesn't, then you know that the data that they're trying to enter is incorrect, and it's going to throw off the information you retrieve out of your database. So you'd want to give the user an opportunity to correct that data before it gets entered into your database. So when we talk about this structure-related terminology, you have to think that each data, or data table I should say, represents a single specific subject. So I like to name a subject as if you think about your English that you learned in high school or junior high, think about a noun. A noun is a person, place, or thing. That's what the data in one table should be about, not about the person and their home, not about the home and their backyard. It should only be about one specific thing, so that everything in that table, each record, is about that one specific thing that you're collecting information on. Every object has characteristics that you can store as data. Okay, so let's see if I can copy this over. So person, place, or thing, each record should be about only one of those items. And then each of those items can have characteristics and store as data. So person might be their first name, last name, so on. A place, Grice Hall, where it's its longitude, latitude, so on. Okay, so hopefully you get a feel for that. The other type of data table you might have is an event table. And an event table sometimes goes by the name of a transaction table. So that table represents something that occurs at a given point in time. So it might be things like your class registration, a sale, a doctor appointment, and it also has characteristics you want to record. So the next thing I want to do is just kind of go back and look at what your book has in terms of diagrams and explain those as they're going along through this chapter. So here we have a document, might be listed like the following as a record. And that record, hold on, would look like the following. It might be broken down like you see here. Now notice we're collecting this information on this form. This is probably a physical form that you can touch. Somebody's filling it out. Somehow the data has to get into the database. Now, part of this is going to be that object table that we were just talking about. So that patient name, that's an object. The event is called a doctor's visit. So that doctor's visit is going to be information that we're going to collect and put in from here. Now, how we do it logically and physically implement that, that's something that we're going to be learning about. But one is the object table, which is probably patient's name and information, and the other one is the event. What did they do and when did they do it, and what fees did they use, what service code, and so on. So I wanted you to get a feel for the two different types of tables that you'll have. I also want to go back and look at this null again that your book is talking about. So when you don't have information here, you've got null, just leave it blank. It means you don't know what the client county is. Now, in terms of being a text value, it's not going to affect your calculations any. But null on the numeric type of field, that's going to affect what you're looking at and the results you get out of your queries. So here we have, when we look at just an aggregate function might be sum, might be average, might be standard deviation. Those are aggregate functions, something that you could do to the entire column or field in a database mathematically. So here it's just doing a simple count, but notice that we have this blank area or null area and it says there's 0 occurrences. Well, that's not right. That's not what we have here. And so we don't know what it's pulling. And so you need to be careful that when you're looking at a null, what information is it giving you back? And then how are you interpreting that? Or are you interpreting it incorrectly? So I'm going to pause right here, and when we come back, we'll start talking about records and fields.